Thanks for joining me today. Let me introduce myself. My name is John DaCosta. I lead the Switch marketing team over at Marvell. And before I get started, let me just leave you with a thought. So our objective at Marvell is to deliver the customer-optimized switching portfolio. And we recognize that not one size fits all. So we have actually not just tailored the portfolio, but also our business model in order to be able to kind of give the customers the most optimized experience as well as the product. So with that in mind, I'll try to do the same with this presentation, and I'll assume that your most precious resource is time. So don't be surprised if I give you a couple minutes back. I'm sure you guys could use it for any other purpose today. So if you're not familiar, let me just take a moment and kind of give a brief introduction to Marvell. So we've actually been around for over 25 years, but since 2016, we've really strategically changed the direction of this company. Made a lot of very particularly targeted acquisitions. Starting in 2016, we made a fundamental change in terms of divesting industry or technologies that are not focused on cloud, not focused on the data center. In 2017 and 18, in 18 and 19, we made 3 targeted acquisitions specifically focused in ASIC and computing and security. And then in 2021, we had a big year where we made 2 very large acquisitions in Inphi and Innovium, focused on high-speed interconnect and optics and low-latency switching. And then this year, we completed the acquisition of Tanzanite, which enables us to advance CXL, specifically for memory pooling and memory expansion applications. That makes us what we are today. And if we add all these things together, we believe that we have the most cloud-optimized data center portfolio with key technologies in all of the 3 major areas of the data center. In compute and security and storage with our Octeon, Bravera, and our custom ASIC silicon. In switching with Prestera and the Terralinx architectures and the PHYs that go along with it. And then in the interconnect with the high-speed PHYs, DSPs, and the optics to go with it. In the future, when you see this slide, you'll see how CXL plays at the compute layer. You should stay tuned on that. For more about what we're doing in CXL, I'd invite you to come tomorrow, Thursday. Thursday will be 2 presentations specifically on CXL. The first is a big memory panel at CXL Forum where Shailesh Thusu, who's the VP of CXL product development, will be part of the panel. And then the second, transforming the data centers with CXL, where Howard Borshu, who is our distinguished engineer from the storage products group, will talk in detail about CXL's role in the future data centers. So why do we do this? We recognize that the growth in the cloud data center is specifically due to an insatiable need for growth in servicing the data requirements. And this is consistent across all the industries. And I'm probably not, this is not something new to everybody, right? But it's very consistent in consumer, a lot of video, a lot of social media traffic, a lot of generation of content. In business with SaaS applications to support crucial business insights and analysis. And then we see more to come in industrial, where data processing is helping in the 4th industrial revolution. And in pharmaceutical, which we can all thank for all the vaccines that we've got, which is where data processing and artificial intelligence are helping to accelerate drug discovery. And then in biotech, with AI being used to identify patterns in genetic data sets, advancing medical research. And then once you have all the data, there's a ridiculous amount of compute in order to manage it, and the infrastructure has to keep up with the requirements of that compute in order to be able to service all those needs for ML and the analytics necessary to support all the services. The bandwidth and the performance has to continue to grow. This is not new. Lots of published research. I've just picked 2 focusing on just the exponential growth in east-west traffic and overall bandwidth. But I would say that the number one thing that we at Marvell are focused on specifically is the green line on the bottom right. So regardless of the traffic, the basic budget for energy consumption remains constant. So for us, the needs of the data center are pretty simple. First, increase the ability to move and process the growing amounts of data. Higher networking bandwidth and compute performance. Drive faster innovation so that the services can increase. And this is not just service deployment and rapid service deployment, but also the ability to build out data centers quickly and efficiently. To do this, though, we have to maintain the focus on TCO, both CapEx and OpEx, where OpEx is particularly important because the energy costs of the data center generally dwarf the cost to purchase the new equipment. So our biggest overall benefit to the data center is through lowering the total power, which has the impact of lowering OpEx, making more of the fixed energy resource available to apply to adding more compute resources in the data center, which is actually where they make money. So it enables more processing power to generate more revenue-generating services. So to meet these expectations, let's figure out how the networking portion specifically of the data center can help achieve these goals. What we see is it continues to evolve to meet the requirements. It's not just about the switch silicon, but it's also about the optics necessary to work with them. It's important to look at both of these together to align to deliver against the data center requirements. At each transition point, the CapEx and OpEx equation is impacted by the two of them, not necessarily equally. For example, on a 32 by 400 switch, 12.8T, what we see is basically 70% of the power is, 70% of the cost is driven by the optics, whereas it's completely reversed for CapEx, where, the other way around, OpEx, where roughly 2/3 of the power is driven by the switch silicon. So we've got to look at this a little bit deeper to figure out how these two things combine. And what we see is that the 51.2T generation, 100 gig SerDes is actually a foundational technology to make these two things work together. And so with Marvell as a leading SerDes technology provider, we think this is going to be a really important play at that transition in the switch. First, we delivered the first 100 gig SerDes in 5 nanometer. And then integrating that into 1.6T copper PHY, introduction of 800 gig PAM4 for electro-optics, and 800 gig PAM4 for copper. We have more on this to come. The reason why we think this is important is because 1.6T optics with 200 gig lambda is instrumental in delivering against the cost and the power for the 51.2T generation. The combination of 100 gig SerDes on both sides of the link and the addition of 200 gig lambda will drive, specifically in the optics, fewer components, resulting in lower power and lower cost. And if we pull back up and we look at the whole system, we can see that each generation has its own specific sweet spot. So for example, at 12.8T, you've got 400 gig optics met this sweet spot in that node. 25.6, 800 gig optics. 51.2, we expect it'll be 1.6T. So based on this, as we deploy this 100 gig SerDes technology across all of the products for this next generation, we believe that Marvell is well positioned for a complete portfolio at this transition. But silicon's one thing, optics are another. Obviously, you need software to be able to deploy it. So let's shift over to that. So if we look at all of the software transitions through the data center, we can see that disaggregation has continued to prove valuable basically every place it's been applied. In Linux, by disaggregating the server from the operating system, really enabling the move away from some architectures to more low power architectures. Second, and third apparently, with software-defined storage, enabling disaggregation away from some storage arrays, and then in software, with the addition of containers, to be able to do cloud-native services and microservices to let the applications operate locally to where the data is being stored. Again, faster innovation, better total cost of ownership, and the addition now of an open marketplace to be able to mix and match different pieces of hardware and software together. We think the next opportunity is within switching. With the disaggregation of a tight hardware-software coupling to a more open and disaggregated model, and the ability to add local third-party support in order to do bespoke deployments and bespoke software deployments for data center applications. Again, same advantages: faster innovation, lower total cost of ownership, and an open model. This is where Sonic comes in. It's the key to being able to support this disaggregation. So over the course of this year, we've increased our investment and presence significantly in both SI and Sonic. We've taken Sonic beyond the traditional use cases, using it for storage applications like eBOF. And we're one of the first to port Sonic to ARM. And then we'll continue investing not just on switch, but also on the integration of support for the PHYs in order to deliver a complete SI and Sonic solution at the system level. And then most recently, we joined the Linux Foundation as a premier member in order to participate in the governance and guidance of Sonic in the Sonic Foundation. And if you want to see how dedicated we are to it, I would invite you to come by the booth where Kishore and the rest of the team will be happy to walk you through our deployment of SI and Sonic across all of the different switching and PHY portfolio that we have, representing both public, private cloud, and edge to core, and end-to-end demo, with Sonic running on every single box. So we think in order to deliver on data center expectations, we really need the balance. We need to balance the need for speed against the cost and power constraints. And we believe that you have to look at all three of the big portions of it: the switch, the optics, and the software to control them both in order to be successful in delivering against the CapEx and the OpEx requirements of the data center build-outs. So with that, thank you. And you get about 10 minutes left.